Alright, so I want to go through in this video about recognizing chiral carbons and how you can actually recognize them, more importantly, when you don't have them. Alright, so let's say I was to give you a molecule that looks like this, and I was to ask you, show me, by the use of an asterisk, where my chiral carbons are. Okay? When we talked about this before, we said that the first thing to do is to rule out all of the carbons that cannot be chiral. In other words, all the carbons that don't have 4 different groups to them. So what we did was we started off with the CH3s and ruled all those out. Then we went to the CH2s and ruled all those out. And then we went to carbons that had double bonds on them and ruled those out too. So that's what we're going to do here, alright? Let's find all the CH3s first, and I'm going to put crosses by them to indicate that they are not going to be chiral, okay? We have a CH3 here. We have a CH3 here, and a CH3 here. You remember, anytime we have the end of a line where nothing is next to it, we have a CH3. And we have one more here. So that's all in this case, 6 CH3s. Next, we're going to look at the CH2s. We'll show this by a cross as well. Now, we don't have anywhere near as many CH2s here. You remember the CH2 is the midpoint of 2 lines, whether those are lines to carbon or bromine or whatever. So here, the midpoint of 2 lines, that's the CH2, so that can't be chiral. This is also the midpoint of 2 lines, that's the CH2, so that can't be chiral either. And then there's one more, it's this one right here. Even though that's a bromine, this is still a midpoint of 2 lines, that's the CH2. So, now we're going to go to the carbons with double bonds on them, and we'll put a cross by them as well. Now, it doesn't matter if those double bonds are to oxygen, or to carbon, or to nitrogen, or God knows what. The fact is, if a carbon has a double bond to something, then there's no way it can be bonded to 4 separate atoms, and so that's why it's chiral, or that's why it's not chiral. So, any carbon that has a double bond to something cannot be chiral. So what I'm doing is putting a cross through all of the carbons that have double bonds to them. In fact, that's all of these benzene ring carbons, as well as any of the other carbons that are in double bonds. So can you see, although we started with a huge number of carbons, we only have a few left. In fact, we only have 4 carbons left. We have carbon 1. We'll just say carbon 1. We've got this one. We got this one. And we got this one. We're not going to look at... nope, sorry about that. We aren't going to look at this oxygen because it's not a carbon. We aren't going to look at this nitrogen because it's not a carbon. Sorry, this is me just... I don't know what I was doing. Anyway, so we got 4 blue dots, and we have to figure out, are each of those chiral or are they not? They're the only ones that could possibly be. So let's look at this one first, alright? Now, if you look at this, coming off this carbon, there is a nitrogen with 2 methyls on it. There is a methyl, oh look, there's another methyl, and then there's a carbon with a C double bond O on it. The thing that's important to note here is, even though I put 2 X's on them, can you see there's a methyl group here and a methyl group here? That's 2 of the same group, and so that means, for that reason, this carbon cannot be chiral, because you've got to have 2 groups, you've got to have 4 groups that are all different. So, let's have a look at this carbon here. You guys can see there's 1, 2, 3 bonds to that carbon, which means we're going to show the 4th bond. I always show it just so I can remember it's there, which is a hydrogen. Now, let's think about this carbon and see what's coming off it. Are there 4 different things? Well, one of the things coming off is a hydrogen. That's this one. Another thing coming off is this group right here, which is a C double bond O. And you guys can tell hydrogen and C double bond O are clearly different. When you look at this carbon, that's not a C double bond O, and neither is there. These are both carbons coming off this one, so whatever I have is going to be different to this. But the question is this carbon different to this one? Well, hopefully you can see that it is, because this carbon has 2 methyl groups and a nitrogen coming off it. This has no methyls or nitrogens anywhere close to it. Alright, so here we've got a carbon we have a nitrogen coming off it, we got a methyl coming off it, we got another methyl coming off it, And I keep losing my pen here. Sorry guys, I don't know what's happening. My pen is not having a good day, evidently. You bastard. Okay, so let's get back to where we were. Where were we? Alright, okay, yeah. This carbon has the two metals and the nitrogen coming off it. This carbon it's got a carbon to another carbon, it's got a carbon to a CH2 with a bromine. There's clearly nothing in common with this. Alright? One other way to look at this is, when you look at this carbon, this is not a CH3, a CH2, or even a CH, because there's no hydrogens on that carbon, that's just a C. This carbon here has a hydrogen on it. That's a CH. So a C and a CH are not the same, which means they're different. So that means that all the groups coming off this carbon are different, which makes this chiral. Let's look at this carbon now. We'll do exactly the same thing. Can you see, first of all, coming off that carbon, there is a hydrogen. Alright? Also coming off that carbon is the CH2 with a Br. Now, you can tell CH2 and Br and hydrogen are clearly not the same. So let's have a look at the other two carbons coming off this one. That's this carbon and this carbon. Well, coming directly off this carbon is an oxygen, a single bond to oxygen. Are there any single bonds to oxygen here? Well, no, there's a double bond, but not a single bond. Meaning, here there's a single bond to oxygen, that's this one, and here there is carbon with a double bond to oxygen. Meaning, because single and double bonds are not the same, all these four groups are different. Now let's look at this last group here, this last carbon. Again, there's 3 bonds shown to the carbon, so I'm going to show the 4th. So coming off here is, there's the hydrogen. Actually coming directly off this carbon now is this oxygen. Hydrogen and oxygen are clearly not the same. Coming off this carbon here is the benzene ring. And hopefully you can already see coming off the carbon this way is not a benzene ring, it's just a carbon with a bunch of other stuff on it. So these 4 are all different. That means 3 of these carbons are chiral. Alright? Let me do just a couple more of these. We have a sugar. I put the aldehyde at the bottom, I shouldn't have done that, but for the purposes of what we're looking at here, it doesn't really matter. There's 1, 2, 3, 4, 5, 6 carbons in this molecule. Alright? I'm hoping you guys can see this carbon cannot be chiral because it's got 2 hydrogens on it. This carbon can't be chiral. CHO is shorthand for aldehyde, so that can't be chiral. Alright? Whenever you have a sugar, it's virtually always going to be the case that the 4 carbons in the middle are chiral. I don't want to go through all the 4 carbons because it's kind of illustrating the same point several times, but let me look at this bottom one. When you look at this bottom carbon, all the 4 bonds to it are already shown, but you can see that one of the bonds to that carbon with the blue dot is to the aldehyde. 1 carbon is to the hydrogen, 1 carbon is to the OH, and 1 carbon is to the rest of the sugar molecule. Meaning, this carbon, or this carbon here, must be chiral. Alright? Now let's look at this carbon. This one that I put a red dot on, and we take a look at it. The groups coming off that, there's a hydrogen, it's this one. There's the OH, that's this one. Coming off this carbon, there's another alcohol, but it's a CH2OH, so it's connected to the carbon before there's an alcohol. Which means this group and this group are not the same. And then when we get down to it, the other group coming off this carbon is all the rest of the molecule. Which makes this one chiral. In fact, that's the same reason why all 4 of these carbons in this sugar are chiral. Now, quickly, we'll just run through this. Alright? I have a whole bunch of carbons here, so I'm going to do what I did before. I'm going to shoot through and get rid of the CH3s and CH2s. Alright? So there's a CH3, CH3. I'm going to get rid of the CH2s, CH2, CH2, and CH2. Actually, there is one more CH3 Can you spot where the other CH3 is? In fact, it's this one. It doesn't matter that it's on a wedge. It's still a CH3. There's one other carbon that I can definitely rule out here, and that's the carbon with the C double bond O, which leaves us with 1, 2, 3, 4, 5 carbons left. Now, particularly when you're in a ring, if it's not completely symmetrical, it's highly unlikely that any of these carbons are not going to be chiral, but let's just check anyway. When we look at this carbon first, all right, with rings we have to be particularly careful about our understanding. Can you see there's a hydrogen, there's an OH. It doesn't matter that they're on a wedge and a dash, it's just a way of showing it's tetrahedral. That doesn't matter at all. What matters is there's a hydrogen and an OH. When you look at the two other groups coming off, can you see that's a carbon and that's a carbon? So in that respect, they look the same. But this carbon, we've already said, is a CH2. Is this carbon a CH2? Actually, no, it's a CH. Which means that all these 4 groups are different, and that accounts for why this carbon is chiral. All right, let's look at this next one. Once I've gone through these two, you'll see it's exactly the same argument for all the others. All right. The only difference about this one is I'm going to actually draw the hydrogen on so you can see it there. Now, so let's see what's coming off there. There's the hydrogen. There is the group coming off, the CH2, and then the aldehyde. There aren't any other aldehydes anywhere, so I'm just going to say that I have my aldehyde group, which is all this stuff. I've already done my hydrogen. Now, we have the 2 carbons in the ring, all right? But the question again is, are these 2 carbons the same? Well, when you look at the first atom, yes, they look the same, but when you think about what's coming off this carbon, there's a H and an OH. I'm going to put the OH on here because, is there an OH coming off this carbon? Well, no, there's a methyl, which means these 2 carbons cannot be the same, and so this is chiral. If you find there's a couple of chiral carbons in a ring, the rest of it's more than likely all the others are going to be chiral too. And in fact, that's what turns out to be the case. And that is how you can figure out if carbons are